So in the question we have that air bubble of radius r rises from the bottom of the surface of the lake. So if this is the if this is the lake and water is filled up to a height, it is filled up to a height h, and there is a bubble over here. It is of radius r1, and when it reaches the surface, its radius becomes r2. We have to find how many times r2 is greater than r1. We need to find this n, and in the question it is given this is r1, this is r2. In the question it is given that r2 is 5 by 4 times of r1. R1 is nothing but r, just normal r. We need to find the height or depth of the lake. We need to, and also the temperature is constant, and surface tension is also neglected. So we can use a formula capital H plus small h is equal to capital H into n cube. Over here n is 5 by 4. N is the number of times the final radius is greater than the initial radius. Capital H is 10 meters of the height of water, and n is also given, it's 5 by 4. We need to find the small h. So 10 plus small h is equal to capital H, that is 10 into n cube. 5 by 4 cube, it's 125 by 64. On cross multiplication we get 640 plus 64, h is equal to 1250. So 64 h is equal to 610. So h is equal to 610 by 64. So this is equal to 9.53 meters. So the option is 3.